Okay, this video is on implicit differentiation. So derive the following functions by using implicit differentiation. Show clear and logical work on the space provided. Okay, number one, we have x squared minus y to the third minus y equals 4x to the fifth power. Let's just derive this one by one. So 2x, right, minus 3y squared, and then dy dx, right, minus dy dx equals 20x to the fourth power, right? Okay, so let's just try to, we're gonna move this to the other side. We're gonna combine all, we're gonna separate each, x and y term, right? So let's just say 3y to the second power minus 1, right? You factor out the dy dx is equal to 20x to the fourth power minus 2x. So that means dy over dx is equal to 20x to the fourth power minus 2x all over negative 3y squared minus 1. This will be our answer. So for number 2, we have a quotient rule situation. So I'm just going to change this into product rule form. So we're going to have x squared times y to the minus 3 equals to 1. So we're going to have product rule. 2x y minus 3 and then plus negative 3y to the power of negative 4, right, and then x squared dy over dx is equal to 0. So we're going to say negative 3x squared over y to the fourth power dy over dx is equal to negative 2x all over y to the third power. Okay, and then dy over dx is going to be negative 2x over y to the third times y to the fourth power all over negative 3x to the second power. Okay, and then negatives cancel out, y cancels out, x cancel out, so we're going to have dy over dx is equal to negative, 2y over 3x. So dy over dx is equal to 2y over 3x. For number 3, we have 18y squared times dy over dx plus sine 3x plus 3x squared equals negative 2y dy over dx. So 18y squared plus 2y. Okay, and then dy over dx equals to negative 3 sine 3x minus 3x squared. So dy over dx is essentially equal to negative 3 sine 3x minus 3x squared all over 18y squared plus 2y. Number 4, sine y minus x squared equals 3. So this would be cosine y and then dy dx, right? Chain rule. Minus 2x equals 0. So dy over dx is actually equal to 2x over cosine y. So for implicit differentiation, it's a little bit different from the other ones because you actually have y values and x values mixed with each other when finding the derivative value. So yeah, if you're getting mix of x and y's on the other side of the dy dx, that means you're on the right track. So don't get confused. And then for number 5, we have to use a little bit of product rule. So we have 3, okay, let's just do 2xy plus x squared dy dx, right? And then minus 2y dy dx equals 3x squared minus dy dx, right? Okay, let's just try to expand this out. So 6xy plus 3x squared dy dx minus 2y dy dx equals 3x squared minus dy dx. So a lot of dy dx's. So let's just put everything to one side. So 3x squared minus 2y, right? And then this will go here, so plus 1, right? All factored out dy dx's, right? And then 3x squared, and then minus 6xy, right? Okay, and then dy dx then equals 2 3x squared minus 6xy all over 3x squared minus 2y plus 1. Alright, and then number 6, also product rule. So let's just leave 2 out here, and then e to the x plus x e to the x, right? And then, yeah, and then plus dy dx e to the y plus y e to the y dy dx, right? And then 2 cosine y, negative sine y, and then dy dx. Okay, so 2 e to the x plus 2x e to the x plus 2 ey e dy dx plus 2y ey dy over dx equals negative 2 cosine y sine y and then dy over dx, right? Okay, and then a lot of dy dx's again, so we're just gonna combine all the like terms. So 2ey plus 2yey, right? And then plus 2 cosine y sine y dy over dx is equal to negative 2x e to the x and then negative e to the 2x. Yeah. Okay, so dy over dx is equal to negative 2x e to the x, and it's 2e to the x all over 2ey plus 2y e to the y plus 2 cosine y sine y. Okay, this will be your answer. Moving on to number 7. Number 7 says, okay, let's just do number 7. It's a little bit too long. So 18